Some atom terminology. Here we go. Number one, most important atom term is the proton. What is it? It's a tiny little particle that is in the nucleus. That's the center of the atom. It has a +1 electric charge, and it determines the identity of an atom. In other words, you can tell who an atom is by how many protons it has. We call that the atomic number. So look around and you'll see a periodic table, probably in your classroom. And if you find hydrogen in the top left, its atomic number is 1. That means it has 1 proton. Look over in the top right. Element number 2, helium. It has 2 protons. So what if you change the number of protons? What if you take a helium atom with 2 protons and you stick in another proton? Well, now it has 3. It's not helium anymore. Now it's lithium, element number 3. So that's what makes protons, or part of what makes protons so important. Just really quickly, what's going on with the nucleus? If everybody in the nucleus has a +1 charge, shouldn't they repel each other? Shouldn't they fly apart? Well, as discussed in the first semester, there's a force called, very creatively named, just kidding, it's called the strong force, and that is holding together the nucleus so it doesn't fly apart the way you would expect. Neutrons, where are they, or what are they? They are also in the nucleus, and as the name implies, they have 0 electric charge. And what do they determine? Well, if you have an atom that has an unusual number of neutrons, more or less than you might expect, you have different isotopes. And that's the topic of another video. But really briefly, let's just talk about how you figure out how many neutrons an atom has. Like, let's say you're looking at helium. The atomic number is 2. That means it's got 2 protons. And the mass number is about 4, so the mass is 4. Please recall from a previous video that the protons and the neutrons are the only particles in the atom that we really bother to talk about the mass of, because electrons weigh so little. So this number right here is the protons, and this number right here is the mass. How can we figure out the neutrons? Well, the mass equals the protons plus the neutrons. So for this element right here, let's say we're talking about helium, the mass is 4, and the protons is 2. So what must the neutrons be? Well, 4 minus 2, or 2 plus 2 equals 4. So the neutrons has to be 2. So this atom of helium has 2 neutrons. So that equation right there will help you solve any problems if you're ever asked how to figure out the neutrons in an atom. Okay, so let's see. Electrons, they are not in the nucleus. They are going around the nucleus. Believe it or not, they actually can spend a tiny amount of time in the nucleus, but that's beyond the scope of this class. They have a -1 electric charge. And what do they determine? Well, if you have an atom that has the same number of protons and electrons, then the plus equals the minus. But sometimes atoms can gain or lose electrons. They can be positive or negative. We call them ions, and we'll talk about those more later. So what makes the electrons so important? Well, the electrons are so important because they determine the chemical properties of an atom. So what does an atom want to do with other atoms? Or does it not want to do anything with other atoms? It is the electrons that determine that. So if you're taking a chemistry class, yes, you are going to learn about protons and neutrons, but really much of a chemistry class is devoted to things that are directly related to the number of electrons and where they are. So electrons, big in a chemistry class. Since I'm under 5 minutes, let me really quickly show you a Google search that I did. I typed in modern atom, and I got these results, or this is part of the results. Take a look at this. This is how, after the Bohr atom, the Bohr model came out, this is kind of how we understood the atom. Here's the nucleus with the protons and the neutrons, and here's the electrons going around, kind of like the moon going around the Earth. And then we gained understanding. We realized that the electron it's so fast, and it's kind of like a probability thing. It can be anywhere in kind of this fuzzy area. So sometimes you'll see drawings like this where it's kind of shaded, and that's where the electron can be. And then we understood that it's a probability of where the electron is at any time. So maybe it's in this spherical area, or maybe it's in this weird dumbbell shaped area. I just wanted you to see that the way that we understand atoms does change over time, and what we know about them is constantly evolving. Just as an example, right here, we've learned that you can take protons and neutrons and break them into smaller parts called quarks. And where does that stop? When do you stop breaking things in half, and when can you stop getting smaller and smaller? I really have no idea.